Hey guys, Mrs. Levenseller here, and today we're going to talk about the law of cosines. So we recently just worked on the law of sines, and I just want to recap a little bit of information about that. So first, we know that we can use the law of sines, we found out last time, when we know two angles and one side of a triangle. So we have to know two angles and we have to know one side. So if you think back to geometry, then we can use the law of sines. I abbreviated that LOS because it's too much to write every time. When we have a triangle that is an angle, side, or an angle, side, angle situation, when that's the information we're given in that particular order, okay? And then just a reminder, if you don't have this written down in your notebook already, that the law of sines is in this box. So A divided by the sine of A is equal to B divided by the sine of B, which is equal to C divided by the sine of C. Now remember, you're never going to make a proportion with two equal signs. You would only use two of those pairs and one equal sign, but any of them can be related, all right? And then if we have an angle side situation from a triangle, so they gave us an angle and then a side and then the next consecutive side, we might not actually be able to solve that. There's a possibility we'll get no solutions or we'll get two solutions. So we're actually going to skip over that for this unit just for time purposes. But if you're curious, you can do some research on the ambiguous case of law of sines, and then you will be able to solve any of the triangles given to you. So today we're going to focus on solving triangles using the law of cosines. So that's your learning target for the day. And again, I abbreviated law of cosines as LOC. So the law of cosines now can be used when we know all three sides of a triangle or when we know two sides and one angle. And remember, our goal is to solve triangles, right? So that means find all the sides and angles. So if we're tasked with finding all of the angles and we only know the three sides, we're going to have to use our inverse trig functions that we worked on a while back. So here, the little abbreviation you might want to add to your notes here, we can use the law of cosines for a side, 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 or a side, angle, side situation. And here is your formula for the law of cosines. Now there's three different versions, but it's all the same formula, right? It doesn't really matter which side of the triangle we label A, B, or C, as long as they correspond to the opposite angles A, B, and C. So they're just giving you three different versions of this in case, maybe I have to solve for A or B, so it's a little less confusing to you. But I usually just remember this one because I've used it so many times, it's burned into my brain. So if you look at the first half, C squared equals A squared plus B squared. What is that? Pythagorean theorem, right? So this is really Pythagorean theorem, but because it's not a right triangle, we have to subtract this extra piece, okay? So we're going to do A squared plus B squared, but then we're going to take away 2 times the side length of A times the side length of B times the cosine of C. And so depending on what we want to solve for, that dictates which version of this we're going to use, all right? So if I wanted to solve for side C, then I would use this equation. If I wanted to solve for side B, I would use the second equation. If I wanted to solve for side A, I would use the first equation. If I wanted to solve for angle A, I would use the first equation. Angle B, I would use the second equation. And angle C, I would use the third equation, okay? So first, before we tackle this equation here, I want us to take a minute and just determine whether we would use the law of sines or the law of cosines for a particular triangle. So let's go around here. I want you to pause the video first and see if you can figure out Would you have to use the law of sines or the law of cosines? And then come back once you're done, and we will go through those questions. So pause, take a second and figure it out, and then come back. Okay, so we said that we can use a law of cosines when we have a side, 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 or a side, angle, side situation. And we can use the law of sines when we have an angle, side, angle, or an angle, angle, side situation. So let's take a look at these triangles and see if we can determine what they're giving us. All right, so for the first one, we have a side. We don't know the next angle, another side. We don't know the next angle, and a third side. So this would be a side, 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 which tells me I want to use the law of cosines to solve. All right. The next one, we know this angle here. We know the side, and then we know the next consecutive angle. So this would be an angle, side, angle situation. And angle, side, angle tells me to use law of sines. So this is one I would solve with the work you did last class. The next situation, the first thing I see is an angle up here, 40 degrees. Another angle is the next consecutive thing, and then a side. So angle, angle, side, angle, angle, side. That would be law of sines again. Maybe you're asking yourself, hey, Ms. Levensiller, I read that backwards, right? And I started with S. So if you had S, A, that's the same thing as A, S, right? Those would be considered the same order. So either one of those would lead you to law of sines, okay? The other ones are symmetrical, so it doesn't really matter where you start, but that's the order you would go in here. And then next, we have side, an angle, and another side. So side, angle, side. So side, angle, side tells us to go with law of cosines, okay? So let's go down below and see if we can do that, all right? So we're going to use the law of cosines. These are the two problems from up above. And if we're solving the triangle, remember you want to find all the missing sides and all the missing angles. Now I'm probably not going to do everything for you just because this video would be quite lengthy. But you can usually figure out once you know another piece of information, after you use the law of cosines, because that's the more complicated formula, then you could use the law of sines to find the other pieces of information, okay? So let's start. We'll call this example A here. So we know between A and B, that side length is 12. B and C, the side length is 15. And AC, the side length is 18. So this is a side, side, side. I know all three sides, but I do not know the angles, right? It does not matter to me which angle I start with, but I am going to start with angle A just for simplicity. All right. So if I'm solving for angle A, let's go up to our formula up here. That means I want to use this formula right here. All right, because angle A is highlighted down there. So that's the formula I want to use for the first one. And we need to first label our sides and then substitute in everything we know. So I'm just going to blow this up so we get rid of that on the side. So remember, across from angle A is side A, across from angle B is side B, and across from angle C is side C. Little variables or lowercase variables are the sides and uppercase are the angles. So let's fill in everything we know here. We have 15 squared is equal to 18 squared plus 12 squared minus 2 times 18 times 12 times, now there's implied multiplication there, the cosine of A. That's the missing piece. That's what we don't know. All right. So let's simplify everything here, and then we will be able to find the cosine of A, or we'll be able to find angle A. So 15 squared is, 225, and then 18 squared is 324, 12 squared is 144, minus, now I'm going to multiply all three of those numbers together at once. 2 times 18 times 12 gives me 432 times the cosine of A. All right. Now we're trying to isolate this whole thing. Remember, cosine of A is stuck together. And you can't take 324 plus 144 and subtract 432 because it's connected here with that multiplication, right? So what we have to do is actually combine like terms and see if we can isolate the cosine of A, that piece that I highlighted. So first I'm going to do 324 plus 144, and that gives me 468. So I have 225 equals 468 minus 432 times the cosine of A. Now I'm going to take away 468. So we get 225 minus 468, which is negative 243, equals negative 432 times the cosine of A. Now if my goal is to isolate the cosine of A, and these numbers are connected with multiplication, I need to do that by dividing. So divide both sides by 432. Now I'm going to use the calculator on your iPad to do this so that we don't mess up anything. So 243 divided by 432, negative divided by a negative is really positive. So I already forgot it. 243 divided by 432 gives me this decimal, right? 0.5625. Now that was equal to the cosine of A, right? And if I want to find angle A, what I need to do is use the inverse function of cosine, right? To solve for an angle, use the inverse. Okay, so we're going to take the cosine inverse of 0.5625, and when we take the cosine inverse of the cosine of A, those two things cancel out and just give us angle A. So in my calculator, I'm going to leave that decimal in my calculator, and then I'm going to do second cosine and second answer. And so we get 55.77 or 55.8. All right, so that would be angle A. Now you have a matching pair, right? We have angle A and side A. So to find angle B and angle C, we can repeat this process to find angle B. Or you could try and set up, actually we'd still have to do that, yeah. So use the law of cosines one more time to find either angle B or angle C, and then you could subtract from 180 to find the rest, all right? So one more example here. Let's look at this, and again I'm going to paste, well first let's figure out what we want. So we have a side angle side situation. We know angle B, so I want to try and solve for side B because that pair is going to give me the value so that I could use the law of sines, right, to help me out. So I'm going to go up and look for the one that helps me solve for B, which would be right here because it starts with B squared. And let's use that, all right? So let's fill in again everything we know. This time we have B squared equals, now A squared is 21, C squared is 13, 2 times 21 times 13 times the cosine of 75, all right? Now on this right-hand side, you see these are all numbers. So what I want you to do is just take that entire thing and put it into your calculator, okay? So let me see if I can do that at the same time. Oh, look at that. All right, so we're gonna do 21 squared plus 13 squared minus 2 times 21 times 13 times the cosine of 75. Let me just make sure quickly. Okay, I'm in degree mode. And I'm gonna hit enter. Okay, so that tells me that b squared is equal to 468.7. And then to solve for b, I'm just taking the square root. So second square root, second answer. Again, I'm not retyping that number. Makes it more exact when you leave it in the answer. So b is equal to 21.65. Right, now you have a matching pair. So you might be able to use that to find angle A or angle C, or you can use law of cosines again. And you will end up solving the rest of your